The In addition to this work, of course, I've been talking mostly about my own work. There have been large numbers of experiments of various sorts. A very similar experiment using naloxone was reported by Mayer and colleagues in Virginia, in which he showed that naloxone blocked acupuncture effects. Unfortunately, other people have been having difficulty with that experiment. Chapman tried to replicate it in humans as well and could not get naloxone to block the phenomenon. So there's a bit of controversy on that point. There's been a large number of studies measuring cerebrospinal fluid in humans and showing that endorphin levels are elevated. There's been a lot of work in China. Uh, I was privileged to be there last summer and visited in 6 weeks about 200 different laboratories to see what they were doing. And basically, they were getting the same kinds of results, namely that serotonin is important, and so is endorphin. This is a more recent and more complicated circuit diagram because we now, first of all, know more about pain than we did several years ago, and we also know more about the acupuncture system. You can see similar pieces, similar elements to the previous diagram. For instance, you can still see the spinal cord here. You can still see the midbrain here. You can still see the pituitary there. And here's the acupuncture needle activating this large diameter fiber, and here's the pain line coming through here. But now we've added more meat to this thing. First of all, if you look at the local circuit here, which is causing endorphin release, we now know that there are small interneurons in the spinal cord, number 9, which release the endorphin and cause presynaptic inhibition. Dark triangles mean inhibition, whereas open triangles like that mean excitation. So we have here, for instance, enkephalins are released at this point and cause presynaptic inhibition. They block number 2 from releasing the transmitter. In fact, we even think we know this transmitter now. It's thought to be substance P, which is a large peptide. And there's very good. It's an answering service. Okay. So we believe that number 9 releases enkephalin at this point and causes a black effect, that it inhibits number 2 and prevents the pain message from getting across number 3, the pain cell. We have very good evidence for this. First of all, we know that if we apply naloxone directly to the cord, it blocks this effect. We know that if you measure the cerebrospinal fluid, you will measure a release of enkephalin from here. But more important, you can do this experiment now in vitro in a dish and show that when you apply enkephalin to this system, this nerve no longer can release its enkephalins or its substance P into the dish. So enkephalins released by 9 prevent number 2 from releasing substance P. This is very well known. In fact, we even know more about that. We know that what it does is prevent the entrance of calcium into these terminals. And calcium is very important for releasing transmitter. The action potential, you see, which enters the terminal of number 2, releases calcium, and it's the calcium which causes the vesicles to release the transmitter, in this case substance P. And endorphins, particularly enkephalin, blocks the entry of calcium. Now, as for the next pathway, the one's going into the brain, the one going into the midbrain through the periaqueductal gray and so forth, and releasing this raphe cell, which causes release of serotonin down here. We've already talked about that. But there's another pathway, number 15, which comes and directly activates the raphe. By doing that, it completely bypasses the endorphin circuits in here. And in fact, we have shown that when we stimulate at 200 per second, normally to release endorphin, we stimulate at 4 per second. 4 per second. When we want to bypass the endorphin system, we stimulate at 200 per second on the needles. That is, these needles here are stimulated at 200 hertz. When we do that, we go through number 15, bypass the endorphin system, and then we have an entirely serotonin pathway, and there's no endorphin involved in that at all.